I'd like to take a few minutes today and explain to you what we currently offer in the Lionel product line in terms of transformers and power supplies. Start with the smallest transformer, which would be the 1.4 amp accessory power supply. This is really nothing more than a variable voltage AC transformer. There are no direction, whistle, or bell buttons on it whatsoever. It's provided simply for powering just accessories, lights, animated accessories, etc. Next transformer we have is the 30 watt PowerMax transformer. The PowerMax 30 watt, 2 amp, about 17.5 volts AC, features a variable voltage, direction, whistle, and bell. It only has 2 terminals on the back which connect to the track or to the accessories. Next is the PowerMax Plus. This is a 40 watt transformer, 17.5 volts, about 2.5 amps. Features direction, whistle, bell, and a variable throttle. It can be used for operating trains or accessories. The next is the CW80. This is an 80 watt transformer which features 4 terminals on the back, 2 for the track and 2 for accessories. There is actually a separate product video on how the CW80 works that explains how to set that accessory voltage. You can adjust that setting manually, and the product video explains that. The 80 watt is capable of producing 5 amps at 17.5 volts AC. The next is the CW80. This is a very early CW80 that has an external power supply. It too features 2 sets of terminals on the back, track and accessory. The external power supply is actually equipped with a 6 amp circuit breaker as opposed to the 5 amp on the current CW80. This one will put out 18 volts AC at 6 amps through this external supply. Next we have the ZWC. The C is shipped in 2 configurations. It was shipped with 2 135 watt 7 amp external power supplies, or powerhouses as they're referred to. You can put as many as 4 powerhouses into this ZWC to gain a total of 540 watts or 30 amps. That would be 7.5 amps per channel, total of 4 channels. It was also shipped with 280 watt 10 amp powerhouses, and also gave you the ability to put 4 10 amp powerhouses into the ZWC for a total of 720 watts or 40 amps, which would be 10 amps per channel. The ZWC has its own product video here on the channel. It explains how this works both conventionally and in command. And finally, our last offering is the ZWL, which will be shipping very soon. The ZWL is 620 watts. Everything is contained within the case of the transformer. Features 4 individual throttles. Also features a voltmeter and ammeter for the 2 handles on this side, and a volt and ammeter for the handles on this side. You can select these ammeters through the handles when you touch them. Again, all of that will be on the product video that will be released very soon. This basically summarizes what we have available currently for the Lionel product line in terms of power. Each transformer has its own unique set of parameters for various applications, which we'll explain to you here very shortly through a series of videos and through the Lionel blog. Today we're going to talk about fixed voltage versus variable voltage and what the differences are. When you're running your train, you're using variable voltage. That means you're increasing and decreasing the throttle to speed up or slow down the train. The direction button basically takes the power, turns it off, and turns it back on. That then cycles the directional state of your train. When you have devices such as accessories like signal bridges or crossing shanties, illuminated accessories like this light pole, or even the crossbuck, the banjo signal rather, you have to understand that if you run all of these off of one transformer, you're going to do 2 things. One, As you increase your voltage to run the train, this light is going to increase in intensity. When you press the direction button, the light's going to turn off. It's going to turn back on. And the intensity of this light's going to follow the throttle on the transformer. That's why we want to talk about fixed voltage. Fixed voltage is a voltage that doesn't change. For instance, these accessories all work exceptionally well off of 14 volts fixed power. Transformers such as the CW80 that have 2 accessory terminals on the back will allow you to set that voltage at 14 volts so that the intensity of this light tower, the animation of this banjo signal, or even the interior light or animation of this gateman shack will be consistent regardless of what the variable voltage on the track is doing. All Lionel accessories, with a few exceptions, but most all Lionel accessories are designed to work at 14 volts AC fixed. Now, as your railroad grows, typically most people will start with a CW80 80-watt transformer. And a CW80 is a good starting place. It gives you the power that you need to operate the train, and it also gives you some accessory voltage to run a few accessories. But as your railroad grows, your power requirements will grow as well. As you continue on this path of building the railroad, you're going to need more power. That power can come from other CW80s from sets, or from separate sale transformers such as the CW80, or the 1.4 amp accessory transformer, or even transformers made by other companies, or earlier post-war Lionel transformers are acceptable as well. And the idea is to operate all of your accessories at a fixed voltage while you operate your train at a variable voltage. The other thing that occurs is on the variable voltage side, you've got direction, whistle, and bell. You want to be able to trigger the whistle, turn the bell on and off. These are all done through things called DC offsets, where it basically shifts the waveform of the AC sine wave up or down to trigger the whistle or the bell. A lot of times these accessories will increase their intensity in the light or decrease their intensity in the light, depending on whether you push whistle or bell. If it's running off of a fixed supply that doesn't have the whistle bell on that waveform, you won't see any change in that intensity. As your railroad gets larger and larger, it may become necessary to move from something like a 30 or 40 watt or even an 80 watt transformer into something larger like a 10 amp or 7.5 amp power supply through some type of voltage regulator. If you're operating in a command environment, there's an accessory voltage controller, which we'll get into in a separate video, but basically that allows you to take a 7.5 to a 10 amp power supply and regulate that voltage to a fixed level. You can even take as many as 2 7.5 amps or 2 10 amps to a regulated level. So you can have as much as 20 amps at 14 volts, which would really be enough to run just about every accessory on almost every layout out there. Again, or not again, but your railroad will really dictate what you need. As it grows and as the accessories and the features of your railroad grow, your transformers or your power supplies will have to grow with it. So there is a difference between a variable voltage and a fixed voltage. Variable will run the train. Variable should have direction, whistle, bell at its disposal. Fixed is just a fixed amount of voltage to run lights and accessories and trackside accessories at a constant voltage. I'd like to take just a few moments and explain to you the difference and the similarities between amperage, voltage, and wattage, and how they apply to your model railroad. Amperage is also explained in the term amps. Voltage is volts, wattage is watts. Amperage times voltage equals wattage. Amperage is effectively the amount of power available. Amps equals amount. voltage is the force available, and wattage or watts is the work that can be performed with the amount and the force multiplied together. To give you an example, we have a 135 watt powerhouse here. We know that it's 135 watts, and we know that it puts out 18 volts. So if we take the wattage, 135, and we divide it by the voltage, which is 18, we come up with 7.5 amps. 7.5 amps just happens to be what the circuit breaker on the front of the powerhouse is rated for. It can also be explained, or a similarity is a hose and water. To give you an example, the amount of water in the hose would be the amperage. The pressure of that water in the hose would be equivalent to the voltage, and the amount of work that is required to get that volume or that pressure and volume, or pressure and volume through the hose is equated in watts, or the amount of work that can be done. There's several AC transformers available on the marketplace, and what's important is that when you're looking at running accessories and running trains on the main line or on the track, you want to look for the higher amperage transformers. So even though a CW80 or an 80 watt transformer will run a typical legacy equipped locomotive, if you put 5 or 6, 7 lighted passenger cars behind it, it's really going to struggle. An 80 watt transformer is a 5 amp power supply. So 6 or 7 lighted cars could pull upwards of 4 amps if it has incandescent bulbs in it, or lamps in it. So you've got 4 amps for your lighted cars. You've only got 1 amp available for the locomotive. You have a quick short on the track. Boom, you've kicked the circuit breaker, the train stops. So when you're running power for the actual track where you're running the trains, you want to get your amperage up. 7.5, 10 amps. Even using things like a TPC with 280 watt powerhouses will give you 20 amps. Your railroad really dictates what you need in terms of power. But a good rule of thumb is to go at least 7.5 amps or higher for the main lines in, that you're going to run your trains on. Accessories, a lot of people have transformers laying around. Some people have post-war transformers, transformers from other manufacturers that are anywhere between 2 amps to 5 amps. Again, if you know what the output, the voltage is, using something like a digital voltmeter or multimeter, you can measure the terminals on the transformer to determine what the output voltage, maximum output voltage is. You can multiply that voltage by the circuit breaker to determine the wattage. If you know the wattage, but let's say it doesn't have an external circuit breaker, you can take the wattage, divide it by the voltage, and come to the conclusion, or come to the answer of knowing what the amperage available is. As you run more and more accessories or more trains off of a transformer, you're taking away those available amps that the transformer provides. So as your railroad grows and accessories, lights, illuminated buildings, animated accessories get added, it's slowly going to take away the available amps. Eventually you'll get to a point where if you have a single transformer powering, say a 5 amp transformer powering all of your accessories, and you have 30 illuminated buildings, chances are the transformer is just going to short out every time you turn it on, because you're taking away more than the 5 amps it has available. So as we get into this series of how to wire your railroad and how to adapt your railroad to command control or legacy or conventional operation, that's going to become very important. It's good to know how many amps you have available on a certain circuit. It's good to know how many amps a particular device uses, and this way you can do the math to calculate, I have so many accessories that will run off of this transformer, so many accessories off this, and so on. It'll prevent a lot of headaches in the future. So as we continue on this video series, want you to remember that amperage times voltage equals wattage. Wattage is the amount of work that the transformer will do. Voltage is the amount of force, and amperage is the amount of available power. So again, track where you're running the trains, 7.5 to 10 amps, even upwards of 15 or 20 amps is preferred, especially if you're running in command or in legacy. If you're running conventional, 7.5 amps is sufficient, 10 amps is better. Kind of the Tim Taylor theory, the more there is, the better you are. Accessories, same thing. It really depends on how many accessories you have, but always keep in mind amperage times voltage equals wattage. As long as you have two, you can determine the third, and then at least you'll know what the transformer is capable of.